Anything article, please? After are you enjoying the opponent so far? Okay, great. It's a great pleasure to introduce today's main guest speaker, Professor Hughes-Hallett. She's from two universities, so she's going back and forth between two. One is University of Arizona, and one is Harvard University. So she's a professor of both universities. And Arizona is very warm, right? Then when it's got very hot, then she goes to Boston, Harvard. Then when it gets cold, then she comes back to Arizona. So she's having an idea like us, because in the Guam, we're just having an ideal climate, right? They're very warm all the year round. But do you think it's going to continue forever? So today, she's going to talk about climate change. So how it is going to affect our lives, people in the world, and also people in Guam. So please just raise her hand. So
thank you very much. First, let me say to all the students here, most people, what I'm going to talk about, the climate, is something that I believe is important for all of you to know about and understand about. Some of you perhaps will become climate scientists as well. Is this better? Oh, okay. Sorry. Thank you. Let me start again. So to the students here, I want to talk about climate change for two reasons. I know that many of you today, inspired by your deans and presidents, are thinking about what you will do in the future. Are you going to come to the university here? Are you going to be scientists? What will you do later on? As you know, you live in a beautiful, beautiful island. And many of you, whether you go to college here or somewhere, whether you major in science or something else, you want to be able, I think, to know how your island world will change or will stay the same. So whether or not you're a scientist, I hope that what I will say today will make sense. I hope that some of you, perhaps many of you, will become some of the scientists, some of the policymakers who will make the world a better place for the climate. There is a lot to be done. There is a lot that you can do, particularly here. Let me also explain, I am not a climate scientist. I'm a mathematician. It is possible, it is important, it is very important that we all learn enough about the climate to be able to understand, to vote well, to plan well, to take care of the future. I'm going to start by talking a little bit about what has already happened in the past. Then I'm going to say a little bit about what the scientists are predicting for the future. Now, I didn't make these predictions. Some of you may make predictions in the future. But my training in mathematics, and I hope that your training in mathematics, will enable you to judge whether the predictions are reasonable. So I'm talking to all of us, whether or not you are sure that you're going to be a scientist. You know the island much better than I. I've been here for 1 day and 2 nights. But there is a lot of information, a lot of it gathered and distributed by the university here, that tells us what's going on. So let's look. I'm going to start with the past. Here are times that some of you remember, perhaps all of you. Tremendous storms, mudslides, floods, all kinds of things. What has happened? The sea fights with the land. The sea takes things away, houses, boats, trees, power cables. It also, paradoxically, makes fires. When the cables break, all kinds of things happen. I want us to think how much of this is just Guam, how much of this is around the whole world. What allies, what friends, what people do you have who are having similar things? Here is Fiji last week and 2 months ago. Huge floods. Here's Philippines just before Christmas. Huge floods. This is last year, but in different places. It's Brazil and China. I want you to think not only about the inconvenience and danger of floods, dry weather, both of them, but about the economic and social disruptions. If families cannot grow food anymore, they must move. Where do you put the refugees? Who feeds them? It's a problem for even the people whose houses are not washed away. It's all of our issues. It's all of our problem. It's not only in Asia or South America or here. This is the US. A little less than a year ago, a tornado, a very bad wind, hit a town, and 124 people were killed. 8,000 buildings were destroyed. This is the US, the mainland US. It's many places. So I want to think first about what has happened so far. I showed some pictures of particular examples, but in the past, several things have happened. And these are facts. These are not projections. These have already happened. The temperature, the average temperature, has risen about somewhere between 0.5 and a degree centigrade during the past century. You might think, well, 0.5 degree, that's nothing. Most places do not have long-term records of sea level, but one contribution that you may be able to make in this island is to think about data that you can contribute to the international discussion. In the United Kingdom, in England, which is where I'm from, there are, in many villages on the sea, there are quite good records of how high the tides came through many, many years. For reasons that are mysterious to me, the churches often kept records of this, and they go back quite some time. This is important because it tells us that around England, the sea level has risen about 5 or 10 centimeters over the last century. India also has some records and shows rise also. I don't know of records in Guam, but perhaps you, in some of your classes, can find some. It would be very useful. why has the sea level risen? Where did the water come from? Did it fly in from outer space? No. The sea level has risen because the North and the South poles, the Arctic and the Antarctic, which are largely made of ice, have started to melt. Not very much has melted yet, but enough to make the sea rise. And in your lifetimes, it is possible that much more will melt. So I hope that some of you are going to go on in your lives to think as scientists, as politicians, as community organizers, to think of ways to control this or perhaps make it better. The big question, of course, is why did the ice caps start melting? I mean, well, partly because it got a little bit warmer. That 0.5 to 1 degree might sound like nothing, but if you're a polar ice cap, if you're part of the Arctic or the Antarctic, 0.5 degree makes a difference. And it has made some things melt. It is believed by most people, at least, not everybody, but most people believe that the carbon dioxide that we produce by driving our cars is what has helped the temperature to rise and the ice caps to melt. So what I'm saying now is accepted by most scientists, but there are some people who argue with anything. For most people, it is believed that the carbon dioxide emissions from factories, from cars, from heating, from cooling, from all of the electricity we use in our daily lives, from our computers and cell phones and whatever, has made the carbon dioxide that we put into the air has made this happen. I'll show you some data, some evidence about this in a minute. Here's some pictures to illustrate the melting of the frozen north. Now, it may be hard for you to believe here in this beautiful warm climate of Guam that there are places in the world which are nothing but ice, okay? But there are. So a glacier is a completely frozen river. And many mountains, the Himalayas in Asia, the Arctic, Greenland, the Antarctic, and in fact many places in Alaska and Russia have glaciers. Here are two pictures that are the same glacier photographed on the bottom in 1941 and in the top in 2004. So it's about 60 years apart. You notice, you can see the same hills, it's the same view. The person who took the photograph was standing in roughly the same place. The bottom one, the river is that's all ice. It's solid, solid ice. In the top one, the river has mostly become water. And the ice you can see just around the corner of the hill to the back. So a huge amount of what used to be ice has turned into water. Maybe you think there's something funny about that particular glacier. Here's another one. Again, this one is a longer time interval from 1909 on the bottom to 2004 on the top. And so it's about 100 years. The bottom one, that great wall of ice, is the end of a river. That's the end of a glacier. Okay? And the glacier keeps all the ice in one place. When it melts, you get a torrent of water coming down, which flows into the sea, doing very bad things on the way because it hurts the farmland on the way. It washes all the farmland from the farms into the ocean, which is not so useful. But the net effect is that there's more water in the ocean and things look bad. There are some good effects. In Guam, you know a lot about how expensive it is to bring goods here. I know that, excuse me, there is a lot of controversy about the way in which everything that's imported comes here. Okay. In England and in Northern Europe, the issues are different, but there's some controversy. England is a tiny country. It has hardly room enough for the people. We have even less room to grow food. We couldn't possibly grow enough food for ourselves. Never mind could we manufacture everything. It's squashed. So most of our food and other things is imported by ship. The ships that come from China, which is many of them, have to go all the way past Singapore, around the bottom of South Africa and up. It's a very, very, very long journey. Some of them go through the Suez Canal, but the Suez Canal is often not a safe place to go. They're always having wars there. 2 years ago, 2.5 years ago, the Arctic melted enough that 2 ships could sail through the Arctic. That's never been possible before. Believe me, they would have done it if they could. It's much cheaper, it's much shorter. But the fact that the Arctic has started to melt has made it possible to go from China to Northern Europe through the North Pole. You've been able to fly over it for ages, but that's different. So the top picture, the red line, shows you where the ice stretched in 1979. The white is the ice cap in 2009. So a lot has shrunk, about 20%. So there are some good things, but mostly the ice melting is dangerous. Let's look a little bit more. So if you become a scientist looking at climate change, one of the things that you will think about is how much the temperature is rising, what caused it to rise, and most crucially, what do you expect to happen in the future? Those of you who are in high school here in the audience, many of these things can happen are projected to happen in your lifetimes. Your children will live in a very different world. So what's thought is that the temperature is rising because of, largely so far, the concentration of carbon dioxide. There's something else that's going to change in the near future, but it hasn't yet changed. At the moment, it's the carbon dioxide. The debate is at the bottom of this screen. Not everybody agrees on this. The debate is about how much of the temperature increase is man-made, how much is natural. Is it just random fluctuations? For those of you taking trigonometry, is it like a sine curve? Or is it a real upward path? And most crucially, what do we expect to happen later? Here's a picture, and this came from a conference at the University of Guam. So a lot of the pictures and explanations I have are from the work at this university. Here is a picture about how greenhouse gases, that's carbon dioxide and things like it, how do they increase the temperature? So the scientific explanation is what's called the greenhouse effect. What that means is that the rays of the sun come through the atmosphere and they hit the earth, and you and me or whoever's standing on the earth, and then many of them are absorbed by the earth or by us and make us hot, and some of them bounce back off our heads or off the ground into the air. If there is a lot or if there is more carbon dioxide in the air, it causes some of the sun's rays to bounce back again. So instead of bouncing off the ground and going up into the air and away, they go up into the air, hit the carbon dioxide, and come down again. This has the effect of increasing the heat. It's like when if you sit in a very, very, very sunny room with big windows and you don't have any AC, you'll be really hot. Okay, same idea. There's some very useful data that was collected by NASA partly and by the Oceanographic Institute. This is the average temperature in the world since 1880. You might think, well, that's not that long ago. Keeping good records over 100 years, good scientific records, is very rare. It's actually a miracle that we have this much data at all. The black line shows the average temperature each year, and it's averaged through a lot of places in the world. The red line has had 5 years averaged at once. It's to smooth out the trend. The green lines, if you can see them, are error bars. They show you how much variation is expected. But even if you look at this half asleep, you can see the temperature seems to be going up. This is what's happened. I copied this a couple of days ago just before I came. They change it every week or so, showing you what's happened. But the average trend is up. Between one year and the next, it may or may not be up because of the variation. This is what the mathematics and statistics can help you with. But the average trend is rather clearly up. Here is another picture from an observatory in Hawaii, which has played an extraordinarily important role in teaching us about the climate. About 50 years ago, David Keeling, who is a scientist, this was in the 50s, before anybody thought climate change had ever happened. Nobody was even thinking about it. He started collecting carbon dioxide samples, and he did it from an observatory high on a hill in Hawaii. So they were above the smog, they were above all the people. It was a very pure air. And ever since the 50s, they have collected this data every month. And it's very reliable data. He was a very, very thoughtful scientist. And the red line is the carbon dioxide readings from 1958, when he started, until very recently, 2011. The black line is the average. During the year between January and July and back to December, the carbon dioxide oscillates. It goes up and down. And the black line shows the trend. You notice, again, there is a strong upward trend. It starts at 320 or a little bit below. We're now around 390. Shortly, we will probably go over 400. All of this is causing more ice to melt. So, Now let's think about the future. Because the world that you will live in, the world your children will live in, is going to be looked at here. During the next century, so that's the lifetime of yourselves and children and perhaps grandchildren, the temperature is expected to rise 3 degrees centigrade. And actually, each time they make new predictions, they get bigger. So it's not likely to be less than 3 degrees, I don't think. The polar ice caps will melt further, and the sea level is projected to rise a meter over the next century. That's probably a fairly conservative estimate. The other thing that may affect Guam considerably is that the storms you get, and other places get, are projected to increase both in frequency and also in severity. So it's important to know about what might happen. Here's another piece that has not come into play yet, but is likely to soon. In Siberia, so that's between Russia and China, but way, way, way far north, there is a lot of land in which the ground is frozen. It's frozen all year, even in the middle of the summer. And the land contains methane. It's a gas that is a greenhouse gas, and it's more effective, unfortunately, at trapping sunlight than carbon dioxide. It's 20 times more efficient. These frozen areas are starting to melt. They haven't melted a lot yet. The two photographs here are from 2005 and 2007, and you can see that there are some puddles starting to form. As they form, the methane gas is going to bubble out of the ground and go into the atmosphere. This is expected to increase the concentration of greenhouse gases and speed up global warming. So it's expected that the rate at which this happens is likely to accelerate. And this is why. It's because of this methane. Let's look at what's projected to happen. I can't find a very detailed map of Guam showing the heights, but this is the best I can do. There's a wonderful site for those of you who want to look at different places called Global Warming Art. And that has maps of the world with the level of the land. So here's what this one is telling you. The blue is the sea. The green is high enough not to be threatened. The red and yellow parts, particularly the red parts, are likely to get flooded. Some of it in your lifetime. There are many places that are going to be more flooded, but Guam is going to feel this, because if the sea goes up a meter, now how big is a meter? Meter is 3 feet, it's this kind of height. That's a lot of sea. So the projections, when you think, I know this feels like a million years away, but when you graduate from high school and you go to college and you think about, you get married and you think about where to live, you may want to think twice about living on the beach, no matter how wonderful it is, because the beach may move and flood your house. So there's going to be economic and social disruption from flooding. It's not just in Guam. These are Louisiana in the US and Florida in the US. Louisiana is where Hurricane Katrina happened, and there was a lot of flooding, partly because they hadn't built proper dikes, but whatever. One of the things that you will need to think about is how are we going to manage this? How are we going to protect it? Another thing that you probably know vastly more about than I is the coral reefs around here they're very sensitive to temperature changes. They're not happy to get a little bit hotter. So you want to think about, this is an issue, the people who are fishing are going to have a very different time, perhaps a very difficult time. Again, it's not just Guam, it's other places. Indonesia, by 2050, you guys are going to be alive then, is going to have its whole airport flooded. They've already had to move the road up because it kept getting flooded. People couldn't get to the airport. The Great Barrier Reef in Australia is projected to disappear in 20 years. Some of the other islands, Kiribati, are probably going to flood entirely. Their president was on television 2 days ago talking about the land that they're buying in Fiji. I don't think you will all have to move here, but people not far away are going to lose their homes. What can you do about it? I know I've been gloomy for the last half hour. Let me say, one of the things that's wonderful about this university and this region is that there is a lot going on. There's both science and things that you can take part in and help. Let me describe, I've put 3 organizations here. I found a lot of information, very well done, at the Pacific RISA website. That's the top one. The Association of Small Island States, which I think you're some kind of member, is also working partly on climate change issues. The biggest international body that you may read about is the IPCC, the Intergovernmental Panel on Climate Change. This is under the UN. And they write scientific reports about what's happening. With any luck, they write them in such a way that the general public can read them, which mostly they do. And they've done a good job, I think, of managing a fairly controversial subject. I want you to think about also, there is to my mind, an ethical issue or a moral issue, which some of you have probably thought about already during this talk. Who is it that produces most of the carbon dioxide? It's not you. It's those big countries. China and the mainland U.S. are busy arguing about who's worse. Okay, the U.S. produces more. The China produces more. The U.S. produces more per capita. There's arguments on both sides. Much of the issue, the carbon dioxide, the temperature rise, is not caused by you. It's not caused by many of the countries that will suffer first. But part of your job, perhaps, as you grow up and think about what to do in the world, will be to convince those big places to listen to you. 2 countries have made, I thought, a useful effort to try and get listened to. So the top picture is from Nepal, which is squashed slightly uncomfortably between China and India. Okay. They're the place that Mount Everest is in the Himalayas. Their problem is melting glaciers. We saw the pictures. I had the pictures from the US, but the same thing is happening in Nepal. They decided that they were going to have a cabinet meeting of their government on the base camp of Mount Everest, because they knew that that would attract the international news media, and that would help them make a statement that we are in trouble. We're small, but you better listen to us. We're having a very hard time. So 2 years ago, they had a cabinet meeting, which is, there they are voting on something. You can see they're wearing gas masks because they're so high up that the air is very thin. And most of the cabinet members were like 70 or something. They had medical teams nearby in case anything bad happened. Okay. But they did attract a lot of national press, so that was worth it. The bottom one is perhaps closer at home to you, is in some ways more similar for the South Pacific region, is the Maldives, which is in the Indian Ocean. They are, like Kiribati, expected to flood completely. The people, there are 400,000 people, they will have to move. They can't stay if the whole country floods. They're a small country, they're not so powerful, and so they wanted, the elevation of the country, to make you visualize it, is the same, the highest point in the whole country is as high as a basketball player. That's not very tall. It's taller than me, but not all that tall. So they had a cabinet meeting at the bottom of the sea. And here is the president of the country signing a document at the bottom of the sea. Why are they doing this? Because they're trying to attract attention. They're trying to say, we matter. Please do something. So, following perhaps the footsteps of some of these people, you may think about how to have climate taken seriously, both in your community, in your island, and in the larger world. Next week, your university is having, I'm proud to say, a conference on sustainability and how to manage the climate. You are already at an institution that is a leader in this kind of work. And I hope that you will carry the great tradition on and do something that when you talk to your children, they will be proud to know that you did for them and for the rest of the world. Thank you.